right, this is the last part four for the video, the last page. So these are all going to be transformation stuff. So transformations. So first one says identify. Okay, well, yeah, identify which answer is best. Okay, so write a description of the rule xy goes to x plus 10, y plus 10, or x plus 10, y plus 8. So x plus 10 means we're going to the right 10 units. Okay, and plus 8 means we're going up 8 units. Okay, so we're going to the right 10 units, up 8 units. That looks like A. It's a translation. 10 to the right, up 8. Yep, definitely A. Look, off to a good start already. 51. Okay. Point A, -2, -10, is reflected over the x-axis. Write the coordinates of A prime. So if we're reflecting over the x-axis, we can draw this out. Two ways we can do this. We can draw it out. So -2, -10 is down here. If we reflect over the x-axis, this is the x-axis here. Okay, so this is -2, -10. Okay, if we go to the x-axis, we're going to stay at -2, except we're going to now be at +10. Okay, the other way to do this is use our rule. So our rule is that AB goes to A negative B when flipping over the x-axis, reflecting over the x-axis. I'm sorry. Got to use my academic vocabulary. Reflecting, not flipping, but they mean the same thing. So our point was -2, -10. So that's going to go to -2, +10, which is what we rationed out there. Okay. 52. Point 24 is rotated 100 degrees about the origin. What is the coordinate of D? Okay, so point D is 24. Okay. We want to rotate it 180 degrees. Well, the rule for rotating 180 degrees is we're just going to flip the signs. So D prime is going to be -2, -4. Positive becomes negative, negative becomes positive. 180 degrees around the origin. So that's going to be -2, -4. That's going to be choice C. Okay, right? It's AB goes to -A. That's our rule. So 2, 4 goes to -2 to -4. 53. What of the following transformations does not result in a congruent figure? So we talked specifically. It's not we didn't. But we talked specifically about isometries. Okay. And 3 of them were isometries, meaning they stayed the same size and shape, right? Congruent figures are the same size and shape. Okay, they might turn, they might reflect, they might be rotated, but they stay the same size and shape. So when you reflect something, okay, you're taking the shape and you're flipping it over, reflecting it over something of some line, so it's not changing size or shape. It just might change orientation, but it's not changing size or shape. Translation, you're just taking the object, moving it right and left, or up and down. Okay, so that one's staying the same orientation and the same size and shape. Rotation, okay, you're going to change the orientation a little bit, but staying the same size and shape. So the one that's not going to result in a congruent figure is dilation. You're changing the size. Congruent figures are the same size and shape. Dilation changes the size unless the dilation is by a scale factor of 1, which is a caveat. 54, what set of coordinates will provide the vertices for translation of triangle XYZ 2 units to the left? So here we have triangle XYZ. Let's plot our points. So our rule 2 units to the left is going to be XY. Okay, it's going to be X minus 2, Y. Okay, point X there is negative 1, 1. Okay, so X prime is going to be negative 1 minus 2, comma 1. Okay, which is going to be negative 3, 1, negative 3, 1. Okay. Y looks like 4, 4. So Y prime is going to be negative, it's going to be 4 minus 2, comma 4, which is going to equal 2, 4. And then Z is 2, negative 2. Yeah, 2, negative 2. Okay, so we're going to Z prime, which is going to be 2 minus 2, comma negative 2, which is going to give us 0, negative 2. So we're going to have 2 units to the left, 2 units to the left, 2 units to the left. There's going to be our new figure. So negative 3, 1, 2, 4, 0, negative 2 is going to be choice B. $55. I talked very quietly there. I'm sorry. It's 7 o'clock now, so I'm getting quite tired. So if this triangle is reflected over the y-axis to form H prime, J prime, K prime, what would be the coordinates of vertex K prime? So we're reflecting over the y-axis. Okay. So we can use the rule or we can count. Let's count first. Okay. So we're reflecting over the y-axis. So this is 1, 2, 3, 4, 5, 6 to the right. So we need to go 1, 2, 3, 4, 5, 6 to the left. This is 1, 2, 3 to the right. We need to go 1, 2, 3 to the left. H prime. This is 1, 2, 3, 4, 5, 6 to the right. So we go 1, 2, 3, 4, 5, 6 to the left. And that's J prime. That would be our new triangle. And then we could just find the coordinates of those points. Or we can use the rules. So K is 6, 6. H is 2, 2. I believe 3, 2 is actually K. H, 3, 2. And then J is 6, 2. Okay, the rule for reflecting over the y-axis is AB goes to negative AB. So we're changing the sign on the first coordinate. So that's negative 6, 6. That's negative 3, 2. And that's negative 6, 2. Okay. The question asks what would be the coordinates of K prime. So that's going to be negative 6, 6, which is C. 56, using the graph below, what is the rule for a translation from point A to point D? So we're going from point A to point D. So we're going 1, 2, 3, 4 units to the right, 4 right, and we're going 1 down. So that's going to be x, y. 4 to the right is going to be x plus 4. Down 1 is going to be y minus 1. So the A. X plus 4, y minus 1. 57. Do we have a rotation? Yes, we do. Okay, good. We got a 90-degree rotation. That's good. Segment CD was dilated around the origin by a scale factor of 2. The endpoints of the image are C prime and D prime. What are the coordinates of the endpoints of the original line segment? So we have a line CD. So C. All right. So we took our points from the original, multiplied by the scale factor, which was 2, and got 4 and 0, and then 6 and 2. So we kind of just have to go reverse. So they're saying what are the coordinates of the original endpoints? So since the scale factor was 2, we dilated the original by a factor of 2. To go back to the original, we need to divide by 2. Okay. So we multiplied by 2, and we got 4, 0. And we multiplied by a scale factor of 2 and got 6, 2. Okay, and we need to find the coordinates. What times 2 is 4? 2 times 2 is 4. What times 2 is 0? 0. What times 2 is 6? That's 3. What times 2 is 2? That's going to be 1. So C was going to be 2, 0, and D would be 3, 1. So it's like going backwards. You got to multiply by half. And multiply by 2 to get here, divide by 2, or multiply by half to get back to the original. 58, point x, -3, -2 is translated using the rule xy, x plus 3, y plus 4. And then reflected over the x-axis. What is the coordinate of x? Okay. So x, let's start with our translation. So we have xy. Okay, goes to x plus 3, y plus 4. So x is 3, -3, -2. So -3, -2 is going to go -3 plus 3, comma, -2 plus 4. Right, 3 and 2, so which is going to be 0, comma, 2. Okay, then we're going to reflect over the x-axis. So the rule for reflecting over the x-axis is AB goes to a negative b. So 0, 2 is going to go to 0, -2. Okay, so our answer is going to be 0, -2. We wanted to graph that out. Okay, our original point was -3, -2. So this was x, -3, -3, -2. We translated it, so we went 1, 2, 3, 1, 2, 3, 4 up. So we got to 0, 2. That's x prime. Then we wanted to reflect over the x-axis. This is the x-axis right here. So it was 2 units up. We want to go 2 units down. So it's going to be 0, -2. That's going to be x double prime. 59. And the last one here. A rectangle is plotted. Okay. On the coordinate plane below, which image shows a 90 degrees clockwise rotation? So let's just do the 90-degree clockwise rotation here and see which choice it matches up to. So let's start by writing out our points. We have 0, 0. We have 0, 2. We have 6, 0. And we have 6, 2. Okay, we're rotating 90 degrees clockwise around the origin. So clockwise is this way. It's 90 degrees, so we're going 1 quadrant over. So these points is going to kind of get rotated down here. Our rule, okay, is to do 2 parts, 2 steps for a 90-degree rotation. One is just flip the numbers, switch the coordinates. So switch the coordinates, 0, 0, okay? And then it's just look at where the coordinates are and see what the units are going to be. Okay, so 0, 0, we flip them, so it's going to stay 0, 0. Coordinates or signs are not going to matter. Okay, 0, 2. Let me actually do this in blue. Okay, it's going to go to 0, 0. Okay. First step, flip the numbers, so that's 2, 0. So if we're going clockwise, are we going to 2, 0 or -2, 0? We're going to positive 2, 0. So here's 0, 0, here's positive 2, 0. Okay. So it's going to be 90 degrees. It's a quarter of the way around, right? This is 360. But we're only going a quarter of the way, 90 out of the 360. Okay. 6, 0, so we're going to flip them. Okay, now we got to look at our coordinates. So again, here's 6. Here's the full circle. We're not going all the way around, though. We're only going 90 degrees clockwise. So we're going to stop there. Okay, and that too. Okay, so it's 0, -6. This is 0, -6. Then we have 6, 2. So we're going to switch them. That's going to become 2, 6. 2, 6 is going to go down into this quadrant here, which is positive x, negative y. So it's positive x, negative y. That's 2, -6. So here's our 90-degree rotation. Okay, and again, the reason this looks weird, I've said this all the time, is the Promethean stretches the board up a little bit. I still haven't looked into if I can reduce that. So these aren't squares here, right? They end up being rectangles because the whole board is square. But this is the same size and shape as this one. It's just the scale is a little bit off because the screen's pulled up. So let's see if that matches any of our choices here. And it matches choice A. So our answer choice here is going to be A. Okay, and that's it for the review, for at least the first review for the final when we all take it with the seniors. That's over 2 hours.